Welcome to The Explainer. Today, we're going to decode the cloud, but we're going to do it from an architect's point of view. We're peeling back all the layers to really get at the essential building blocks that make our digital world tick.
Just stop and think for a second about your favorite apps, the websites you visit every day, your streaming services. All of it runs on this massive global infrastructure that's just mind-bogglingly complex. But what are the actual fundamental pieces that make it all work? So, how do we figure that out? Well, we got our hands on a kind of insider's key. We're looking at official cloud architect exam questions. But here's the thing, we're not studying for a test. We're using them like a decoder ring to reveal the core decisions, the trade-offs, and the secret building blocks that architects use to build the entire digital world around us. Okay, so every great project, I don't care if it's a tiny app or a global service, it all starts at the same place. You have to build a rock-solid foundation. And in the cloud, that means carving out your very own secure, private corner for yourself. Back in the day, everything was kind of thrown together on one big shared network. Think of it like a giant open-plan office. The modern way, the right way, is the virtual private cloud, or VPC. This is the difference between that shared desk and your own private office with a locked door. You control everything, who comes in, who goes out, and that control, that's the absolute bedrock of modern cloud security. Now, this private cloud isn't just an idea. It exists in real physical places. You start by picking a large geographic region, say US East. Inside that region, there are multiple, totally separate data centers called availability zones. Now, for resilience, to make sure your app stays up, your private network can stretch across a few of these zones. But, and this is a key architectural rule, a subnet, which is like a specific street address in your network, can only exist in one of those zones. And that hierarchy is how architects build apps that can survive an entire data center going offline. All right, so you've got your secure foundation. Now you've got to face the next great challenge, the real world, which is totally unpredictable. How do you design a system that can handle a sudden, massive flood of users without just falling over?
Just imagine it. You launch a new game, and boom, it explodes overnight. The handful of servers you set up are suddenly drowning. Are you going to stay up all night, frantically adding more machines by hand? No way.
Of course not. You let a service called autoscaling handle it. It's kind of like a smart thermostat for your app. You just set a simple rule, like, hey, I always need at least one healthy server running. If that server fails for any reason, poof, autoscaling launches a brand new replacement instantly. It is automated resilience. It's the secret sauce to an always-on application. But scaling isn't just about having more servers. It's about being fast. When a user makes a request that has to go all the way to a traditional database on a disk, that round trip can take 200 milliseconds. Now, that might not sound like a lot, but to a user clicking around, that feels like an eternity.
So what's the architect's trick? It's a caching layer, basically a super fast pit stop for data that sits right in front of the slower database. Now, for the most common requests, the answer comes from this fast lean, and it slashes the response time by like 90%. That's the secret to an app that feels snappy and responsive.
And this brings us to a really critical choice that every architect has to make, because not all database copies are the same. For disaster recovery, you need a perfect, synchronized, standby copy in a totally different data center that can take over instantly if the main one dies. That's a multi-AZ deployment. But for performance, you need multiple copies that can all share the load from users. Those are called read replicas. So you see, one is for survival, the other is for speed. They're two different tools for two very different problems.
Okay, but the fastest, most resilient system in the world is totally useless if it isn't secure. And that brings us to the next pillar of good architecture, locking all the digital doors and controlling exactly who has access to what.
One of the very first, most critical pieces of security advice an architect learns is this. It sounds so extreme, doesn't it? Delete your keys. But there's a very, very simple reason for it. And it's because the root user is basically God mode for your entire account. It has absolute, unrestricted power to do anything, and I mean anything, including shutting down your entire operation and running up the bill.
The core security principle is least privilege, which just means you never use the root account for daily tasks. Instead, you create limited users with a tool called IAM, giving them only the exact permissions they need to do their job and nothing more. The root account gets locked away in a digital vault.
So how does a developer on the testing team get secure temporary access to the live production environment? You definitely don't share passwords. Instead, the production account creates a special role. Think of it like a temporary security badge with very specific permissions written on it. A user from the testing account can then assume that role, and they get a temporary key to do only what that badge allows. It's a secure, auditable handshake between different parts of your organization.
All right, for our final section, let's talk about data. The modern world absolutely runs on data, and the cloud gives us this incredible suite of tools for storing it, managing it, and analyzing it at a scale we've never seen before. Picking the right kind of storage is a huge decision for cost and performance. I mean, you wouldn't use a bank vault to store your weekly groceries, right? It's the same idea here. For things like images, videos, and backups, you use highly durable object storage like S3. For the virtual hard drive that your server actually runs on, you need the super fast block storage of EBS. And for all that data you have to keep for years but almost never look at, that goes into the ultra-low-cost archival storage, Glacier. Matching the data to the right storage type is a fundamental way architects keep costs from spiraling out of control. But what happens when you need to analyze a truly massive amount of data? I'm talking about a petabyte. That's 1,000 terabytes. It's an amount of information that would just completely crush a normal computer. How do you find the needle in that colossal haystack?
Well, you use a specialized tool that's built for exactly this problem, a data warehouse like Amazon Redshift. It's designed from the ground up to just tear through petabytes of data at incredible speeds. And crucially, it keeps all that heavy-duty analysis separate from your main application, so your big data questions never slow things down for your actual customers.
Now for our last concept, and honestly, this one is a real game changer. It's called cloud formation, and it lets you treat your entire infrastructure, your servers, networks, databases, the whole shebang, as if it were just code. You write a template file, basically a blueprint of everything you want, and CloudFormation goes and builds it all for you. But here's the real magic. If any single part of that blueprint fails to build correctly, maybe a misconfigured network setting or a wrong permission, the entire process doesn't just stop. It automatically rolls itself back, deleting everything it just created. You're left with a perfectly clean slate. This guarantees that you never end up in some broken, half-deployed nightmare state. It's the ultimate safety net. So, as we've seen, all these services, VPC, auto-scaling, IAM, Redshift, CloudFormation, they aren't just a random collection of tools. They're more like Lego bricks. They're the fundamental building blocks that architects click together to assemble the vast, complex, and resilient digital world that we all rely on every single day. These principles, these tools, have made the power to build things on a global scale more accessible than it has ever been in human history. This isn't just for massive corporations anymore. It's for everyone. It's in your hands. So the only question left is, what will you create?